In section 5 of chapter 3, we are going to be doing my favorite factoring technique. The reason it's my favorite factoring technique is because it often makes the most challenging problems much easier right at the very beginning. If you don't know this technique, the problems will be much more difficult, and then you'll just have to employ this technique later in the problem. The other thing that's very useful about this is, thus far you might have noticed all the problems I've been giving you to factor, they've all been quadratics. They've all been x to the second power. This technique is what allows us, it opens the door for us to start factoring polynomials. That is to say, x to the third power, or the fourth power, or the fifth, or the sixth, or the seventh, or whatever power we want. It is one of the techniques we can employ. The technique is called greatest common factor. You will often hear me abbreviate it as GCF. This is my favorite factoring technique because it makes hard problems simpler, and it also makes unfactorable problems suddenly become factorable. Like, for example, number 1, I have 2x minus 10. You might look at that and go like, Mr. Silva, that's not factorable. It's not x to the second power. And you would be wrong. That is factorable. The way that I utilize GCF is I look at each of the terms and I ask myself, what number or what value can divide into all the terms? So what number can divide into 2x and negative 10? 2. And this is just 2 times the quantity of x minus 5. GCF is just the distributive property. Just backwards. So the distributive property, we normally distribute this 2 to both terms. And that would give us the 2x minus 10. GCF is just the reverse of that process. And you'd be surprised at how often that is useful. For example, problem number 2, I have 12x squared minus 3. As it's written currently, that's not factorable. At least not using any of the techniques that we have currently. You can't use an area model on it. You can't do a difference of squares because 3 is not a square and neither is 12. However, as long as you do GCF first, by looking at these two terms, I realize like, oh, these are both divisible by 3. I'll get 3 times the quantity of 4x squared minus 1. And now all of a sudden that stuff that's in the parentheses, that's a difference of squares. That's factorable again. So GCF, greatest common factor, allows you to unlock the ability to factor problems that were previously unfactorable. And additionally, I haven't done an example yet, it'll make complex problems to factor a lot easier because it makes big numbers small. And remember, when we're factoring, big numbers are harder to do. This technique makes them smaller, so it makes the harder problems easier. So whenever you're factoring a problem, every single problem that you ever come across and you have to factor, which is going to be a lot in this class, your first step on every single one of them should always be the same. You should ask yourself, can I do GCF? If you can do GCF, do it. If you can't, then move on to your next set of factoring skills. So problem number 3. I could factor that as it's written using an area model, or I could realize that 5x cubed, 10x squared, and 40x are all divisible by 5x. And then that'll leave me with, on the inside, x squared minus 2x minus 8. And all of a sudden, that problem, which would have been a pain in the butt to use an area model on, now it just turns into an x squared minus 2x minus 8. I could do that without even doing an area model. I could do that in my head. But I'll still do an area model just for good practice. Numbers that multiply to give me x squared are x and x. Numbers that multiply to give me 8 but have a difference of 2, it's 4 and 2. So that'll give me a 4x and a 2x. Those two will combine to get me that negative 2x as long as the 4x is negative and the 2x is positive. So I need a plus 2 and a minus 4. I'm going to make a mistake on this next step. I want to see if you can catch it. So my answer is x minus 4 times x plus 2. This is one of the most common mistakes that people make. What was it? I don't want an answer yet. I want everyone to get an opportunity to think about it. What mistake did I make? Think about it. Every single one of you are going to make this mistake. I make this mistake. It's very common. All right, who's got it? Forgot the 5x. The one downside about GCF is because it's so quick and easy to do, and you do it right at the beginning, a lot of students forget to write it down on their next step after they do an area model. It's still there. It's still hanging out. Don't forget to write the GCF that you pulled out. Problem 4. This one actually isn't GCF because I can't pull a number out of a 16 and a 1. They both don't have an x. This is just an area model problem. Actually, no, this isn't even an area model problem. You could use an area model, it'll work, but there's a faster way. This is just 4x squared if you squared it. This is just 1 squared. I should have known that because it's a binomial. That means this just turns into 4x squared plus 1 times 4x squared minus 1. Once again, that second term, the 4x squared minus 1, is factorable again. Because this is a perfect squared. That's just 2x quantity squared. This is a perfect squared. That's just 1 squared. And they are both being subtracted. So this is going to turn into 4x squared plus 1, because that's not factorable. There's a plus sign between them. Times 2x plus 1 times 2x minus 1.